Okay, can all of you see the screen? Shared screen presentation?
Yes, sir.
Yes, sir.
Yes, sir.
No, sir.
Yes, sir.
Some of you, it will take, just check your net connection. You should be able to see it. Some of them are able to see it. Alright, so we have already started with the resultant, and we have started with problems on the non-concurrent, non-parallel force system. And we have solved some basic problems, so we'll continue with that. And just a quick recap, we have in the last lecture we studied how to find moment and how to find couple, what is moment and what is couple, and we also studied the method to find out the resultant of a non-concurrent non-parallel force system. So in case of non-concurrent non-parallel force system, all the forces do not line of action of all the forces acting in the system, they do not intersect at a single point. Okay, so this kind of force system is called as non-concurrent non-parallel force system. And to find the resultant of such force system, you have to resolve all the forces. Then you have to take the summation of the forces in x and y direction and apply the sign convention. For example, you always use right hand side positive and upwards positive for summation fx and summation fy respectively. After that, you have to find the resultant by squaring and adding, and then take the square root of the summation fx and summation fy, and angle you can find out by summation tan inverse of summation fy by summation fx. Okay. In questions, you will be also required to find the x-intercept and y-intercept. Okay, so for example, the resultant is somewhat like this as shown in the figure. Okay, so it will cut the x-axis and y-axis at 2 points. Alright. So you have to find x-intercept and y-intercept of the resultant force, and that is given as x-intercept is given as summation m divided by summation fy, and y-intercept is given as summation m divided by summation fx. Yes? Hello?
Yes, sir.
Yes. Any question?
No, sir.
Okay. All right. So now we'll have to understand one more concept, that is resolution of force. So you have studied resolution of force in x and y direction. Okay. Now we have studied resolution of force into a force couple system. So resolution of force into a force couple system. So suppose there is this force R acting at point A. Okay. Now you have to resolve this force into a force couple system at B. Okay. So what I'm going to do, I'm going to add and subtract R, and direction of R is parallel to this original force R. Okay, so I have actually done nothing. Okay, just added and subtracted a force at point B, and magnitude of R, this R and this R is equal. Okay, and both are parallel to each other. All right. So now these two forces, the one which are of equal magnitude, these two pair of forces, equal magnitude and opposite direction, they will form the couple, and magnitude of that couple will be given as R into D.
Then find out by which formula you will find the area. Use a ruler to find P. Find the area of the shape whose dimensions are given below.
So somebody has left his mic on. Switch it off. Right. So this is the equivalent force coupler system. So couple value is given as R into D, and we are replacing the same amount of force R at point B. Okay. Now instead of representing the system at point A, we are representing the system at point B. Alright. So this is how you do it. Any questions? Alright. Okay. So let's do one example. So a 50 Newton force is applied to a corner of a plate. This is a L-shaped plate. Okay. Determine the equivalent force couple system at point B. All right. So first, let's resolve this 50 Newton force into horizontal and vertical direction. So this is 50 cos 60, and vertical one is 50 sin 60. All right. Now take the moment of this resolved forces about point A, and let's use this sign convention. Clockwise is forward. So that becomes equal to 43.50 cos 60 into 100 minus 50 sin 60 into 50. Right, so calculate this. Yes, what's the answer? Value?
Sir, 334.93.
No. See, this is 50 into 100, and it's nearly 50,000. Yes, anybody else?
334.93 आएगा.
334.9. What is 50
Yes.
cos 60?
25.
No. 50 cos 60 is not 25. 50 cos 60 is 43.
25.
सर cos 60 तो हाफ होता है ना. So 50 into half is 25, isn't it?
Okay. All right.
Yes,
So
25.
all right. So what you are getting? 330.
334.93.
I'm sorry. I wrote the equation correct.
सिक्किम भी है छोटू सा सिक्किम.
No. I have written
हाँ
it.
ये और ये सिक्किम छोटा वाला.
It is 50 sin 60. I'm sorry. And this is 50 cos 60. Okay. I'm
हाँ
sorry.
पर करना पड़ेगा. एक सेकेंड. मे बी वो कंफ्यूज हो रहा है काउंटिंग में.
Sir, 3080.12.
Correct.
But the
3080.13.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22,
Hello,
23, 24,
somebody
25,
is
26, 27, 20.
Ishika Jain. Your mic is on. All right, so the equivalent system is this 50 Newton force at A and making an angle of 60 degrees with the horizontal and a clockwise movement of 3080.13 Newton millimeters. All right. So your equivalent force coupled system at A will be something like this. All right. Any questions? All right. So let's continue. A force of 500 Newton is acting at A, produces a clockwise movement of 1200 Newton meters about point O. Find the y-intercept of the force. Give the equivalent system with force acting at O and find the coordinates of point A. Okay, so three things they have asked. So first thing you have to find the y-intercept. So I will extend this, and this is your y-intercept. That is what they have asked. Okay. So this is the y-intercept, and they have also asked the coordinates of A. So this is XA and this is Y. Okay. And they have also asked the find the equivalent system at O. Okay, so we'll calculate one by one. Right. So let's first find out the y-intercept. Now to find out y-intercept, we have to find the moment of the force about O. So summation M about O is given as 1200 Newton meter, and that is clockwise. Okay. And then you're also, so how to find out y-intercept? What is the equation? Y-intercept is summation M about O divided by summation Fx. Okay, so that will give you the y-intercept. And summation Fx is nothing but the cosine component of this force, that is equal to 500 cos theta, and theta is this angle. Alright. So how to find out theta? So here the proportion is given. Okay, the vertical one is 3 and horizontal is 4. Okay, so this is another way to represent the angle. So in this case, theta is calculated as tan inverse of opposite side, that is 3 divided by 4. And so find out what is theta and find out summation fx. Substitute that in the summation fx equation and find out the y-intercept. And tell me the answer. If you have any questions, please ask immediately.
Sir, theta is 36.87.
Correct, 36.87 or 36.86.
Sir, can we directly write cos theta as 4 by 5?
Yes, you can in fact. Okay, so this is very good. Okay, so see, this is 3, this is 4, so obviously the hypotenuse is going to be 5. Okay, and this is your angle theta. Okay, so cos theta is adjacent side by hypotenuse 4 by 5, that is equal to 0.8. So you can definitely write it like that also. So if you are able to make that transformation, then you can definitely write it like that.
Summation fx is equal to 400.
400, and y-intercept is
3.
3. All right. So this is the y-intercept. So we have got the y-intercept. Now the second thing is you have to give the equivalent system with the same force acting at O. Okay. So equivalent system will be simply a 500 Newton force which will be constructed parallel to the original force, and this angle will be same, this theta, that is equal to 36.86 degrees. All right, and in addition to that, there is also a moment which is acting in the clockwise direction. All right, so it will be like this. All right, so this is the equivalent system. Equivalent system will be it will be 500 Newton, angle 36.86 degrees, and clockwise force of 100. Alright, so that is it. Now last thing they have asked you to find the coordinates of point. Alright, so how to find the coordinates of point A? So let's see. A has two coordinates, so XA and YA. Alright. XA is already known. What will be XA? XA is 1 meter. Alright, this is the X coordinate. Now you have to find out Y coordinate. So how to find out Y coordinate? Take moment about
write the equation of line.
Take moment about O. Okay, so in clockwise direction, and we already have that as 1200 Newton meters. Okay, now resolve this force in horizontal and vertical direction. So this will be 500 cos theta, and this is 500 sin theta. So that is equal to 500 cos theta.
सर वो 1 मीटर ऑलरेडी दिया है ना क्वेश्चन में, गिवन है ना?
हाँ, it is given. That is this is given. So this is 500 cos theta into YA minus, that is this distance, this is YA into 500 minus 500 sin theta into XA, that is 1, nothing but XA, and this is equal to 12. So we have assumed the same convention when we are calculating moment over here. Okay, so the cos component will exert a clockwise moment, the sin component will exert a anti-clockwise moment. Right. So calculate y.
So 8/3.
No, no, not 8/3.
15/4.
15/4. Yeah, that is the correct answer. But see, when you write the answer on your calculator, that is a button SSD.
3.75.
So 3.74.
Correct.
3.75.
I mean, you can write it in this way also, but this is a better way to write the answer. Okay, so this is 3.75. All right. Okay, so let's go to the next question. Any questions? Are all the three parts of the question clear? Okay. All right. So next, determine the resultant of the given force system. Also find out where the resultant will meet arm AB. Okay. So what I'm going to do, I'm going to take A as origin and AB as the x-axis and the vertical arm as the y-axis. So let's calculate summation fx. Right hand side positive is equal to 100 plus 50. So now again this is, now earlier it was 3/4, now this is 4/3. So this angle theta is tan inverse of 4/3 and that is equal to 53.13 degrees. Right? So if it is 3/4 then it is 36.86 and if it is 4/3 it is 53.1. Both total we will get it as 90. So this is 50 cos 53.13. Calculate summation Fy upwards positive is equal to minus 80 minus 60 plus 50 sine 53.13 and calculate. Then also calculate summation M about A clockwise positive, that is equal to 100 into 2 plus 80 into 3 plus 60 into 6 minus 50 sine 53.13 53.13 into 9 and calculate.
So
Sir, why you
fx
took
is 130.
Yes, fx is 130 and you are getting it positive, so it is in right hand side direction.
Fy is minus 100 Newton.
Minus 100. Is 100 Newton. So we are assumed upwards positive, it is coming negative, that means 100 Newton is in downward direction. Okay, so your fx is like this.
Sir, why you took 60 into 6?
60, we are taking moment about point A na. So 60 into this perpendicular distance. So that is 3 plus 3, so that is 6.
Okay, sir.
Moment is 440
440 Newton.
Newton meter.
So your direction of the resultant is in this direction. This is your resultant. Okay, this is your summation fx and this is summation f. Okay, and this is the angle. So let's you already used theta over here, so I will call this as phi. So this is my x-axis, this is coordinate axis, this is the resultant. Now moment is what is summation m? 440 Newton meter, correct? And it is in clockwise direction. Okay. So the direction of the resultant I already know. This is summation fx, and this is summation fy, and the resultant is like this. And this is the angle phi. Phi will be tan inverse of summation fy divided by summation fx. Okay.
So 37.56.
Correct. 37.56 or 57, if somebody chooses to round off in that way, 37.57 degrees. Okay. So the direction of resultant is this way, and about this origin what we have chosen, that is A, it should produce a clockwise movement. So you have to place the resultant accordingly. So the only way to do it is place the resultant in the first quadrant. So this is the resultant, right? And this is your arm AB. And this is the angle, that is 37.57. So you're required to calculate where it cuts the arm AB, or in other words, you are required to calculate the x-intercept. Now we are going to go one step. So since we are practicing, we are going to find the x-intercept as well as the y-intercept. Okay. So x-intercept will be given as summation m divided by summation fy, and y-intercept will be given as summation m divided by summation fx. Okay, so calculate. Just tell me the answers.
So x-intercept is 4.4.
4.40.
Y-intercept is 3.38.
3.3.
3.38. All right. These are the answers, and this is how you represent the result. Now suppose I want to find out what is the distance, perpendicular distance from point A to the line of action of force R. I want to find this value T. Okay. So how do I find out this distance? I want to find out. Sometimes the question might be in this fashion also. Okay. So find out D. So to find out D, what do I do? Take summation m about A and just simply divide it by the R. Okay. Because the resultant is acting at this angle theta. All right. So calculate. You already know the value of R. You already know the summation of m about A. Calculate R. So I'm just marking the value. This is 4.4 meters and this is 3.38 meters.
So 2.68.
2.6. Okay, so this is 440 divided by resultant, that is 164.01, and this is 2.68 meter. Okay, now I can also calculate by using this triangle. Okay, I'm marking with these 3 dots. And so this is theta. So alternate angle, this also will be theta. Okay, and this is forming a right angle triangle. Okay, so I can find out d by using this sine theta is equal to d divided by x intercept. That is equal to d divided by 4.4. Okay, so d is 4.4 times sine. So substitute the value of sine theta and let's check if you are getting the same answer. I hope everybody has followed the last step, what we did. If you have any questions, please ask immediately. Yes, how much you are getting?
Same answer.
Same value, sir. Okay, so we are getting the same answer. You should get the same answer. Right, that is 2.68. So there are multiple ways to arrive at the answer. Use the method which is most suitable to you. Okay, one more example. Not the one more. We are going to do a lot more examples today. Right? Find the resultant of the four forces acting as shown in the figure. Also find the intercept of the resultant on the x-axis. Choose a suitable coordinate system. Now they ask you to choose a suitable coordinate system. So I am going to again take this A as the coordinate origin, and this is my x-axis. This is my y-axis. So summation fx right hand side positive is 70.7 cos 70.7 cos 45 plus 200 cos 30 plus 100 cos, and summation fy is equal to, say, upwards positive is 200 sine 30 minus 70.7 sine 45 minus 80 minus 100 sine. So calculate summation fx, calculate summation fy also you calculate. Yes, tell me the values. R will be square root of summation fx square plus summation fy square, and the resultant angle will be tan inverse of summation fy by summation fx. Yes, tell me the values.
Sir, fx is 309.80.
Correct, 309.80 kilonewton. Fy
Minus 80.
minus 80. So this is coming out as minus 80.
80
So that is
Newton downward.
correct. 80 kilonewtons downwards. Since all the units are kilonewtons, so it will be 80 kilonewtons in downward direction. Okay, so your forces are in this fashion. Okay, so this is summation fx, summation fy. Calculate the resultant and the angle theta.
So resultant is 319.96.
Correct, 319.96 kilonewton. kilonewtons, and theta is 14.47.
14.47.
Okay, 14.47. Right. Now they have also asked you to calculate the x-intercept. So let's calculate that. So x-intercept will be summation m about a divided by summation f. So calculate. R, your again it will be in the first quadrant. This is your R, because it has to exert. I hope everybody is able to understand how I am placing this R in the why in the first quadrant, why not in the any other quadrant. I hope that is clear. If you are not clear, you should ask. Because the moment you have calculated. Okay, moment equation I have not written. So summation m about a. Just write it over here. So summation m about a is 70.
Sir, x intercept is 309.81.
No, 309. 309, that is such a huge number. No? So all are in 1 meter. So let me write the moment equation. Then you just recheck your equation what you have written. So plus 200 cos 30 into 1.5 minus 200 sin 30 into 1 plus 100 into sin 30 into 1. So now calculate.
Sir, how did you
How
calculate
much?
it again?
Pardon? I did not get it, what you are saying.
Sir,
Can you
can you
repeat?
explain the moment of a how did you calculate? Means
See, I am resolving all the force component. Okay. So this is 70.7 cos 45 and this is 70.7 sin 45. Okay. Alright. Then this is 200 cos 30, 200 sin 30. This is 100 cos 30. This is 100 sin 30. So now let's take moment of all these forces one by one. So let's start with 70.7 cos 45. So that is in clockwise direction. So force into distance. So 70 cos 45 into distance is 1.5. All right. So that's why the first term. Second term.
Sir, moment is 421.39.
Just hold on. Just hold on. Let me just complete the explanation. That is not correct. Okay. Second term 200 cos 30 into perpendicular distance again 1.5. Okay, cos 30 into perpendicular distance 1.5. Now this sine component that is in that will create a anti-clockwise moment about point A. Okay, so that is 200 sine 30 into distance is 1 meter. Okay, then the last force 100 cos 30. See, cos 30 is going through point A, so the no moment due to the cos component. Similarly, no moment due to the sine component over here because it is passing through point A. Okay, only the sine component of 100 sine 30 will be having moment about point A. So that is, and again it is in clockwise sense. Okay. So this is 100 sine 30 into the distance is 1. Okay, so that is how I get the equation. Is that clear
okay, sir,
now?
got it. Yes, sir.
Okay.
Sir, moment is 284.79.
Correct. 284.80 and the units will be Newton, kilonewton meter. Okay, this is kilonewton, this is meter. So you can write it as kilonewton.
Sir,
Alright.
x-intercept 0.91 meter.
No. So this is summation, you have got it 284.80 and what is the summation Fi you have got? Okay, you have calculated 80, right? It is 80. So divided by 80. Calculate this, how much you are getting.
3.5, sir.
3.56 meter.
Correct. So this is your resultant and this is the x-intercept. This is how you construct the line. Any questions? Let's do a few more. Alright, determine the resultant of the system of forces shown in the figure and locate the point where the resultant again cuts E. Okay. So let's calculate summation effects by resolving all the forces one by one, starting with this 100. So that is equal to 100 and I'm going to use the convention right hand side positive. So 100 cos 30 minus plus 150 cos 50 minus 80 cos 60 minus 75, sorry,
120 cos 70.
120, correct, 120 cos 70. Okay, so that is the summation fx and summation fy vertically upwards positive will be 100 sine 30 minus 150 sine 50 minus 50 minus 80 sine 60 plus 120 sine 70. So calculate summation.
Sir, Fx is 112.
Correct, 111.96 newtons. So you can definitely round it up to 12, 112 newtons. And summation Fy. Yes, summation Fy is
So minus 68.27.
minus 68.27. Okay. So that is 68.27 or 68.28, which is what I am getting. 28 newtons acting in downward direction. Okay, so this is your summation Fx, summation Fy.
So we actually completed 9 years opening the park. So annual certificate goes up like 500 people of teachers from engineering colleges getting special tickets there. So yesterday I had come and met your principal everyone. So I couldn't meet all of you because I came a little bit late. So sir told you have to come today and you have to finish for everyone. So almost जो है so we are giving special passes like this आपकी और आपकी families के लिए एक पूरा साल भर valid रहेगा from today till end of December. So जब भी आप family के साथ या friends के साथ उधर आने के लिए plan बनाते हैं एक booklet के साथ आ जाइए और entry gate पर present कर दीजिए.
Okay, so this is the R and this is angle theta. So calculate R is equal to square root of summation Fx square plus summation Fy square and calculate theta tan inverse.
Sir, 131.17.
31.17.
131.17 Newton and theta
31.37.
correct 31.37. All right. Okay, now we have to calculate the x-intercept and the y-intercept. So let's calculate that. They have actually asked only the x-intercept, but we are going to calculate both. Okay. So to calculate that, first we have to calculate the moment. So summation m about A. Summation M about A. So one by one, let's resolve. 150 cos 50 into 2 plus 150 sin 30 into 4 plus 50 into 2 plus 100 cos 30 4
4 root 2.
100 sin 30 into 4 minus 80 cos 60 into 4. Calculate. X-intercept summation M divided by summation Fy divided by summation.
Just inform me about the and then decide just left and then take left, same left, and then that is
Calculating. Yes, calculating.
सर इसमें 150 cos 50 तो पास कर रहा है ना ए से ए बी से, मतलब
150 cos 50
वाला कंपोनेंट हम क्यों कंसिडर कर रहे हैं?
See, this is 150 cos 50. This is 150
sin 50.
sin. Okay. So I am taking moment about A, na?
Yes sir.
So this will have moment about A.
Yes, okay, yes I understood. Sorry, I understood.
Sir, moment is 659.24.
No,
267.48.
no.
Sir, why did you take 150 sin 50 into 4?
See, sine component. This is sine 150 sine 50, right? 150 sine 50. Okay. So for a line of action of the force into perpendicular distance. Right. So how much is the distance total? This is 2 meters. This is 2 meters. So total is 4.
Okay, sir.
So
899.24.
580.
No,
Is it 580?
no, no, no.
899.24.
No.
So 738.87.
738.87.
738.87 is the correct answer. How can there be so variable answers for same data? Alright. Okay. So please check your calculations and also calculate the x-intercept and the y-intercept. Just tell me the x-intercept and y-intercept. Is anybody calculating?
So 10.82.
10.82 is the x-intercept. And
6.59.
6.59 is the y-intercept. Correct. Final answer is all right. Okay, let's go to the next one. A square fixed board EFGH carries two pulleys A and B, which carry loads of 20 newtons and 40 newtons respectively, with the help of cable fixed at point K and J as shown in the figure. The diameter of each pulley is 400 mm with reference to the x and y axis shown as the coordinate axis. Coordinates of the centers of the pulleys are 1, 4 and for A it is 1, 4, 1, 4 and for B it is 4, 1. Okay. Find the magnitude and direction of the resultant forces on the board, the x-intercept and y-intercept of the resultant. Okay. So let's start by the free body diagram. So this is 20 Newton. So if I just consider the rope acting on the pulley, so this will be 20 Newtons and this will be 20. Okay, and this is 40 Newtons and this will be 40 Newtons. Okay. So if I just construct it, this is how it is going to look. Okay, so I am going to remove this part and I am just going to replace it with the forces. Okay, so A is 1 comma 4, B is 4 comma 1. And angle made, this is 30 and this is 60. Now I am going to transfer this force to the center. And when I transfer it, I can simply write it as this is 20 Newton and this is 20 Newton vertical. And this is 40 newtons and this is 40 newtons. Can I do that? Is that okay? Any questions about the transferring of force? Yes, anybody? Is that correct? This is the way I have transferred the force.
Yes, sir.
Any questions how I transferred the force? Have you understood how I transferred the force directly to the center? Without
Yes,
taking
sir.
into account the...
Yes, sir.
पास ले लेंगे क्या करते हो मेरा नाम बोलेंगे
नहीं वो सबको बांट ले
वो राहुल 1400 का पास कौन लेगा
1400 रुपए
तो
नहीं वो फ्री में दे रहे हैं
1400 का पे कर दिया है
Okay, see, I don't know whether you are followed how I done this. See, this is 20 Newton force at 60 degrees. So what I am going, this is resolution of force into force and couple, right? So I will write 20 Newton in this way, okay? So diameter will be say 400. So the this pair will create a couple. That magnitude will be 20 into 400. Okay, in which direction? Counterclockwise direction. Similarly, if when I do the transfer of the 20 Newton force and resolve it into force couple system, again this 20 Newton force will also form a force couple system, but and the magnitude of that will be again 20 into 400 because the diameter is same and it will be in opposite to this earlier couple, right? This will be in clockwise direction. All right. So this is 20 into 400 counterclockwise and this is 20 into 400 clockwise. So they will cancel each other. Okay. So that is why I can directly transfer the forces at the center. I hope everybody has followed that. Okay. All right. So let's continue. So I have transferred the force. Now next step is to resolve these forces. So resolve these forces in horizontal and vertical direction. So this is 20. So this is 60 degrees. So this is 20 cos 60 and this is 20 sin 60. Okay, and this is 30 degrees. So this is 40 cos 30 and this is 40 sin 30. Okay. And let's mark the distances also. So coordinates of A, this is A is 1 comma 4. Okay, so X is this is 1 meters and this is 4 meters. Okay, this is my origin. This is 4 meters. And B is 4 comma 1. Okay, so let's mark the distances for point B also. So this is 1 meter and this is up till this end. So this is 4. Okay, so now I have got all the, I think this is called as H. So let's write it H. H is the origin. Okay. So now let's calculate. So these are the coordinates. So I have marked the coordinates. Now let's calculate the moment about. Okay, so these are the coordinates I have marked. Cleaned up the slide, and let's calculate the moment about H. And let's say clockwise positive. Okay, so that is equal to 20 into 1 minus 20 cos 60 into 4 plus 20 sine 60 into 1 plus 40 into 4 plus 40 cos 30 into 1 minus 40 sine 30 into 4 is calculated. Has everybody followed the moment step? Any questions regarding that?
Sir, fx is 10.
No,
Sir, why you took minus 40 sine 30?
because this is acting upwards, na? Okay, so this
No,
will create
clockwise.
a
Okay, clockwise.
counterclockwise, not clockwise, counterclockwise.
Sir, 24.64.
No,
fx.
fx. Okay. No, I want a moment first. Fx is correct. 24.64 is correct. So let me write the summation fx equation also. So summation fx is right hand side positive. So minus 20 cos 60 minus 20 cos 60 into minus 20 cos 60 plus 40 cos 30. So that is the fx, and summation fy is equal to minus 20 sine 60 minus 20 plus 40 sine 30 minus 40. Tell me the values. Summation fx, somebody has already told me it is 24.64, right? Right hand side, positive. Tell me the moment value and summation fy value.
Sir, moment of hedge is 111.96.
Correct.
Sir,
196
111.96.
positive, right? Positive
Yes, sir,
value.
positive.
Yes, sir.
And summation Fy?
Sir, minus 57.32.
Minus 57.32 newtons. So that is equal to 57.32 in downward direction. It's in downward direction. Let me just go to the slide, all the calculations. Right? So this is summation fx, summation fy, and then calculate the x-intercept and y-intercept. That is summation m divided by summation fy, summation m divided by summation fx. So this is the result. And we have pasted it again in the first quadrant. Okay. Now just tell me. Now suppose summation m, whatever we have got, suppose that is negative. Okay, all the other things remaining same. Okay, these all things are same. This is summation fx, summation fy. Okay, and so now where will you place the resultant in this case? See, if you are getting summation m as negative, that means the moment is in counterclockwise direction. Okay, because our assumption when we are writing the moment equation is clockwise positive. Okay, so you got a counterclockwise moment. You got the direction of the resultant as shown by this r with theta reference to summation fx. So now where will you place the result?
Second quadrant.
Second quadrant. Where? Here, like this. Is this correct?
Sir, fourth quadrant.
It's like this. Or let me ask it in another way. Say, let me erase this. Instead of asking in terms of quadrants, let me ask you in terms of axis. Okay. So now let's get back to our case. So in our case, summation m is positive and resultant is in the direction shown. So the resultant cuts both the positive y-axis and positive x-axis. Okay. Now moment is negative. Okay. So this is the positive x-axis. This is the positive x. This is positive y. Okay. And this is negative x and negative y. Okay, so the direction of the resultant is same. Okay, this is same, only the moment is now negative. So which two axes will it cut? You followed the question, na? See, you have to place the resultant in this coordinate axis such a way that when you take the moment about this origin, it should produce a counterclockwise moment, and the direction is as shown by the arrow. So it should be aligned to that direction and it should exert a counterclockwise moment at O. Alright, so direction is fixed. This is the direction that you cannot change. Alright. So
Negative x and
negative x and negative y, correct. Okay, so this is how the resultant should be placed. Okay, because you can get problems where it always might not be positive. Now let's do some more. Let's see. This is the positive y. This is positive x. This is negative x, and this is negative y. Okay. Now suppose I get this summation fx as this way, okay, and summation fy, better, summation y. So this is my summation fy and this is my summation fx. Okay, just a arbitrary case I am asking. Okay, and this is the resultant. Okay. Now say suppose summation m I am calculating for all the forces and it is coming out to be clockwise. Okay. Now which two axes should the resultant cut?
Positive x and negative y.
Positive
X and negative y.
positive x and negative y. So you are saying positive x, so it should cut positive x and negative y. So it should be like this. Is that what you're saying?
So negative x and positive y.
Okay. So somebody is saying negative x and positive y. Okay, so this is option 1 and this is option 2. Okay, so which is the correct one? Both cannot be correct. And this is the origin O about which we have calculated the moment. This is summation m about O. You are assuming that it is clockwise positive and the moment coming out to be clockwise. So which is the correct one?
2.
2, right? 2 is the correct one because this resultant will exert a clockwise moment about 0.0. So 2 is the correct one. All right. So option 2.
सर ये कैसे डिटरमिन कर रहे हैं कि मतलब 1 और 2 में 2 जो है वो क्लॉकवाइज
This is the resultant. Okay, this is the resultant which we have got, right? Okay, this is how I am getting this arrow because I am getting this summation fy upwards and summation fx right hand side as positive, and in between rise the resultant. This is the angle theta. All right, that is how I got the direction of the resultant. Now the direction of the resultant that is getting fixed. Hello. Go ahead. हाँ 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 हाँ
Thank you.
एक मिनट, मैं जस्ट ना मेरा लेक्चर चल रहा है. हाँ, एक 10-15 मिनट बाद बात करेंगे. हाँ हाँ ओके ओके. मेरे को बस स्प्रेडशीट भेज दीजिए, मेरे को मेल में भेज दीजिए ना आपका कि हाँ हाँ भेज दीजिए, मैं देखता हूँ फिर हम लोग डिस्कस करें. ओके ओके ओके. Okay, correct. So this resultant is in this direction and it should exert a clockwise moment about O. Okay, so if I place it, if I choose option 1, then the moment exerted by the resultant force about O will be which direction? Okay,
Anti-clockwise.
Anti-clockwise. So which is not the case, which is not what you have got. So it is violating the whatever we have derived. Okay. Does that clarify why option 2 and not option 1?
Yes, sir.
Huh? Okay. Now let's go. Suppose now this was, we calculated summation and this came out to be counterclockwise. So now which is the correct option?
1. Option 1.
Okay.
Option one.
Yes. Okay,
Option
so I
1.
hope you have followed how to place the resultant. So correct. Option 1 is the correct one. So you should analyze it in this way whenever you are getting this kinds of problem. Always it may not be, the resultant may not be in this fashion. Okay, it can be any way. It can be this way, it can be this way, correct? Or it can be this way. So all 4 ways are possible. Alright. Okay. Okay, think about it. If you have any doubts, please ask. Now a very small portion is remaining. That is the simplest form of force system. That is the parallel force system. Okay. So in a parallel force system, to find out the resultant, what we are going to do, just add all the forces algebraically, because all the forces are parallel to each other. Okay. And apply a suitable sign convention. For example, upwards is positive and downwards is negative. Okay. So the resultant, for example, whatever system I have chosen, say suppose I chose downwards resultant, upwards positive. Okay. I choose the resultant, that sign convention is upwards positive. So this becomes minus F1 plus F2 plus F3 minus F1. Whatever forces are in downward direction are taken as negative, and whatever forces in upward direction are taken as positive. Okay. Now to calculate moment about O, again use the same some sign convention, say clockwise positive, and calculate moment about O. Summation F you already know, and summation M about O divided by summation F gives you the distance of the resultant from O. So that is how you work for a parallel force system. As the name suggests, all the forces in this type of system are parallel to each other. Okay, so this is the simplest form of force system. So we'll do some examples on this. Determine the resultant of the parallel forces shown in figure. Okay, so let's calculate the resultant. So summation Fy, say take upwards positive, so that is equal to minus 200 plus 500 minus 350 plus 150 plus 200. Okay, so calculate.
Minus 700.
Minus 300, na? How much? Not
700.
minus 7. How much you got?
Minus 700.
No. Calculate. Be careful. So these are minus one. One's first is minus. This is plus, minus, plus, plus.
Plus 300.
Plus 300. Correct.
The plus 300.
Plus 300 newtons. Correct. Okay. So that is in the upward direction. So this is your resultant. Okay. Now take moment about O. So that is equal to. So starting this, choose this as origin. So moment of this 200 newton, it is passing through origin. So that is 0. Okay. Minus 500. So I am taking clockwise positive. So minus 500 into 3 plus 350 into 7.5 minus 150 into 10 minus 200 into 1 is equal to how much?
Minus 575.
No.
12.
Minus 200 into 12, sir.
Minus? Not 12, minus 12. That is wrong.
So 775.
Correct. No, not 775.
Minus 775.
No.
Sir, 575 minus.
Last bit minus 200 into 1 आता है या 12 आता है sir?
minus 2775.
Correct. Minus 2775 Newton meter. So that means this resultant is in 2775 Newton meter and it is in counterclockwise direction. Right? So we have
Sir,
to next we
कैसे
have to find
calculation के?
next we have to find the
Sir,
distance.
200 into 1.
Oh, sorry.
575 ही होगा.
Oh, I'm sorry. See, this 200 I have made a mistake. Plus 4.5 plus 2.5 is what? 7. It is 12. 12. I'm sorry.
हाँ, अब होगा.
Okay. So then find out the distance. So resultant is acting somewhere upwards, and so you have to next find out the distance d. So I have to find out the distance d. So this is my resultant r, and I have to find out the distance of the resultant from O. Okay, so d will be summation m about O divided by r. Calculate.
So 9.25.
9.25 meters. Okay, so that is 9. Okay, so that is the correct answer, and this is how you represent. All right. So last example for today's lecture. Resolve the force of 1200 Newton at C into parallel components at A and B. Okay, so there is a force at C, and this you have to resolve into a parallel force system at A and B. So let's make this parallel force system, and let's call this as F1 and F2. Okay. So summation M about A for this original system is 1200 newtons into 1000. Okay. That is the moment, and it is in clockwise direction. So this is clockwise. Okay. Now let's do summation F for this force system. So that is equal to F1 plus F2, and since I have shown it downwards, let's write downwards positive. Okay. So and this will be equal to 1200. And summation M about A for this parallel force system F1 F2 is equal to F2 into 600. Okay. All right. So equate this two. This is equal to F2 into 600 and find out F2. Yes, how much is F2?
So 2000.
2000 newtons, correct? It is 2000 newtons. And what is the direction we have assumed? F2, it is in downward direction. So this is in downward direction. Okay. So similarly, find out. So from this, you know, F1 plus F2 is 1200. So find out F1.
Minus 800.
Minus 800. Okay. So it is coming minus 800. That means F1 is
Upward direction.
Upward direction. Okay. So this is the correct way to represent a system. So F1, F2. F2 is in fact in upward direction.
तो सर मतलब पैरेलल कंपोनेंट्स में अगर रिजॉल्व करना हुआ तो मतलब ऐसे फोर्स पेयर्स लेने जो कि जिनका मतलब मोमेंट इक्वल हो.
The moment should be equal and the direction should be parallel to the original.
F1 में नेगेटिव नहीं लिखा है.
Pardon?
F1 में नेगेटिव नहीं लिखा है. नेगेटिव 800. Okay, डायरेक्शन बता.
I have changed the direction, na? So I don't write it negative. And F2 is 2000. Okay, so this is the equivalent force system. Got it? Any questions? Simple, right? All right, now let's do this last part. Replace the 1200 Newton force at C by a force couple system at D. Okay, so let's do this. Okay, so 1200 Newton force at I want to replace it by force couple. So what I'm going to do is simply add and subtract 1200 newtons at D. 1200 newtons, 1200 newtons, and so this. These two are opposite, so this becomes moment becomes 1200 into 500, and it is in which direction now? It is in the sense of rotation is in this way, so it is in counterclockwise direction. So calculate that. How much is that?
$6 lakhs.
500. Huh? So let's divide it by 1000. So let's convert this into meter. So tell me in terms of Newton meter, because these are all in millimeters. So instead of writing such a huge, it is correct. The 6 lakhs just divided by 1000
600
and
Newton meter.
600 Newton meters, correct. 600 Newton meters. Okay, and it is in counterclockwise. Okay, so this is the equivalent force system. Let me just write it over here. A, B, C, and D. And at D, it is a downward force 1200 newtons and a counterclockwise moment of 600 Newton meter. Okay, so that is the final force. All right, that's all from the the resultant chapter. I have uploaded all the notes except for today's lecture. So today's lecture I will be uploading it sometime. Few minutes I will upload it. Okay. Any questions? All right, that's all for today then. Thank you. See you next time tomorrow.
Thank you.
Bye.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
You have got the
Thank
earlier.
you, sir.
You are able to find it in the class materials folder, right?
Yes, sir.
Okay.
Yes.
Recording
Yeah.
we are not able
So
to
if
manage.
I have any questions, I also uploaded the manual for solving. If you have any questions, you can just post the question on the Teams chat, and I will
So can
respond.
you upload this PDF by today itself?
Yes, yes, I will upload it immediately after this, after like 15 after an hour. I will upload. Okay, thank you.
Bye.
Bye.